In this video, we are to compute question on SARIMA model. The given model is this, and we are asked to find the SARIMA model for 101,110. For more on this topic, you need to subscribe to this channel. Solution. We should recall that SARIMA PDQ and PDQS is given as file B, file the seasonal parts. We also have our difference, the seasonal parts, our time series, the moving average parts, the seasonal moving average parts, and our error term, or known as the white noise. So we now have to define each of these parts in respect to the question that is given. Now we should note that PDQ, we can use it to compare 101. That means PDQ. Then here is capital letter P, capital letter D, and capital letter Q. Also, it means that the whole of this is P, the whole of this is our capital letter P. Why this is the seasonal difference, and this the small d, this our time series, while here is our small q, and this part is our bigger q. So the next thing to do is to compute. The whole of this part, which is our p, is just 1. So 5b is equal to 1 minus 1b, just 1. So we end it here. The next one we have p. Our big P is also 1. So we have the seasonal part is equal to 1 minus 1s, and we have our s to be 2. So we write 1 over 2 b. This b, we have it as s here. So since we have this b, the big P, which is the big P is just 1. So we write our s value here, which is just 2. Also, we have this, our seasonal difference. Our seasonal difference is computed as 1 minus ds. So we have ds here, which is equal to 1 minus b multiplied by s. Big B, 1, multiplied by s. Our s here is 2. So 1 multiplied by 2 is equal to 1 minus b raised to the power of 2. Also, for the small d, we have it as 1 minus b all over raised to the power of b, small d. So we have it as 1 minus b raised to the power of small d. Our small d is 0. So this is 0. Anything raised to the power of 0 is 1. Also, we have for the moving average, we have our 5b, which is small q. Small q is 1. So we write 1 plus theta 1 b. This is supposed to be 1, and we leave it like that because it's just 1. Then for the moving average, the seasonal part, we have theta s b raised to the power of s is equal to 1 plus our big Q is 0. So our big Q is 0. It means we'll be having nothing here. We shall be having nothing here because it's 0. Of course, if we want to write out something, we write 1 plus This is theta 1, 0, b raised to the power of s is supposed to be here, which is 2. So since this our q is 0, it means we are not putting down anything here. We are not putting down anything. The next thing to do is to write our model with what we have just gotten from all of this. So if we write out the SARIMA model, which is phi b, the seasonal part, the difference to be equal to the moving average now. For what we got from phi b, we got 1 minus phi 1b. What we got from the seasonal part, we got 1 minus phi 1, 2, b 2. From what we got here, we got 1 minus b squared. Here we got 1. So we write down our xt. Also for this function, this part, we have 1 plus theta 1b. For here we have nothing because there is 0. So we put our et. So this becomes our model for the SARIMA 101 110 seasonal 2. So this is how we can compute the SARIMA model for SARIMA 101 110. For more on this topic, you need to subscribe to this channel.